Alright, now that we know the basic structure of atoms, what they're made of, we're going to talk about reading elemental symbols, reading the symbols that tell us what we have, essentially. What atom do we have and what particles exist inside the atom. So every elemental symbol is going to have this basic structure here, where we have the symbol from the periodic table in the middle. This will always be one or two letters, and the first letter will always be capitalized, and if there is a second letter, it will be lowercase. It will not be capitalized. If the element that you're looking at is charged, so it has more or fewer electrons than protons, the charge is going to go in the top right corner here. The mass number for that element is going to go in the top left corner. Now the mass number is the number of protons plus the number of neutrons. So it's the protons and neutrons added together. That is the mass number. And then lastly here in the bottom left corner, if you want to put it in there, this one is optional, and usually it isn't put in there, but sometimes it is. This is the atomic number, and this is just the number of protons. So it is the atomic number from the periodic table. It's this top number here. Okay, so let's look at a few examples here. I'm going to walk through a few of them with you, and then I'll have you pause the video and do some on your own. So the first one here, let's see, we have magnesium. And for each of these, we are going to, if the mass number isn't given, we're going to assume it's the same as the mass number on the periodic table. So in this case, we have magnesium. If you go back to the periodic table, what you'll find is the magnesium is element number 12, and that it has a mass number of essentially 24. We're going to round it off. We'll talk about why it's not exactly even in a later video. But for now, we're going to just round it off. So if we have magnesium, and it has an atomic number of 12, that means it has 12 protons. That's what we're trying to find here. We're trying to find the number of protons, the number of neutrons, and the number of electrons in each of these elements here. So it has 12 protons. If the mass number is 24, and we have 12 protons, that means that we must have 12 neutrons as well. Because remember, the mass number is the protons plus the neutrons. So if the mass number is 24, and the number of protons is 12, then the number of neutrons must also be 12. Because we're not given a charge here, we're going to then assume that we have the same number of electrons as protons, which is that's not really an assumption, actually. I shouldn't even call it an assumption. If there is no charge given, then that is the person that wrote the symbol telling us that we have the same number of electrons as protons. So, this one, kind of boring. 12, 12, and 12. 12 protons, 12 neutrons, 12 electrons. That is magnesium. Let's look at, let's look at a slightly different one here. Let's look at lithium. So, lithium, if you go to the periodic table, has 3 protons because it is the third element. It is actually the lightest metal because hydrogen is not a metal. So it has 3 protons by definition. The mass number from the table is essentially 7. So because the mass number is 7 and we have 3 protons, that means that it must have 4 neutrons. Because again, the mass number is equal to the number of protons, which is 3, plus the number of neutrons, and so this must be 4 for that to be true. And then lastly here, the number of electrons is going to be 2. because we have a positive charge. And that positive charge does not mean bonus. We got a bonus electron. It means the opposite, actually. The element is positively charged because it's missing a negative charge. It is missing an electron. And so that is going to be 2. It's going to be the number of electrons. So then the last one I'm going to do here with you until I have you do some of these on your own, we have sulfide, is what this is called. If you look at sulfur on the periodic table, it has 16 protons and a mass number of 32. So we have 16 protons. If the mass number is 32 and we have 16 protons, that means that we must have 16 neutrons. The charge is -2. Usually that's written with the number first like this, so it's 2 minus is the charge. That means we have 2 extra electrons as compared to the protons. So we have 18 electrons. We have 2 extra negative charges. All right, so I want you to work these 6 here on your own. Pause the video and do that. But I do want to just point out here that these 3, so the uranium, the chlorine, and the oxygen, they do in fact have the mass numbers given. So you do not have to go to the periodic table to find the mass number. Actually use the mass number that's given to you. So go ahead and pause the video now and see if you can work that out. Alright, I hope you paused the video there and tried to figure these out on your own. So I'm going to go through these fairly quickly. First one here, iron. It's element number 26, if my memory serves me, on the periodic table. Yes, it is. And it is essentially 56 is its mass number. So if we have 56 for the protons and neutrons added together, 26 protons, that means that we must have 30 neutrons. And there's no charge given, so we're going to have the same number of electrons as protons. Oxygen 15. Oxygen is element number 8 on the periodic table. It normally has a mass number of 16, but now we have 15 as our mass number, and so that means we must have 7 neutrons, because again it has to have 8 protons. That is the definition of oxygen, is that it has 8 protons. So if it has 8 protons, it must have 7 neutrons. There's no charge given, so it must have the same number of electrons as protons. Aluminum 3+. Aluminum is element number 13 on the periodic table, and it has a mass number of 27. So if we have 13 protons, 27 is the mass number, it must have 14 neutrons. And then we have +3, 3+ as the charge. So that tells us that we have 3 more protons than electrons, which means we only have 10 electrons. Chlorine 37, or chloride, actually, 37. Chlorine is number 16, which is, no, 17, not 16. Yeah, so chlorine is number 17. So it has 17 protons. If 37 is the mass number for chlorine, that means that it must have 20 neutrons, this particular isotope of chlorine. And then it has a negative charge as well, so that means it has 1 more electron than proton, so it has 18 electrons. Uranium-232. Uranium is element number 92, I believe. Yes, it is. Here it is down here. So element number 92. 92 electrons, or sorry, protons. and actually it will be the number of electrons as well, because if you notice here there's no charge. And so because there's no charge, that means we have the same number of protons and electrons. Relatively common mistake for students to make is they say, oh, there's no charge. That must mean there's no electrons. No, 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 no. That means that there is the same number of protons and electrons. If the mass number is 232, that means that we must have 140 neutrons, because that will give us, if we add 140 and 92, that will give us 232. So then the last one here, hydrogen. Hydrogen is element number 1. And so it is going to have 1 proton. There's no charge given, so it's going to have the same number of electrons. If you look at the periodic table, hydrogen has a mass number of 1. So, does that mean we have 1 neutron? No, we already accounted for the 1 here with the proton. We have 0 neutrons. So hydrogen, most hydrogen anyway, does not have any neutrons. There are actually isotopes of hydrogen that have neutrons. Those are called deuterium and tritium. But the vast majority of hydrogen is just a proton and an electron. All right, let's work through these real quick, and then we will call it for this video. So this is having us go the opposite direction. So now we're given the information, and we're going to write the symbol. So this is an ion with 35 protons, 45 neutrons, and 36 electrons. So 35 protons, that tells us that this is element number 35, which is bromine. So we know that is going to be our symbol. We're told that it has 45 neutrons and 35 protons. So that means that the mass number is going to be 80. Those two added together. The mass number is the protons and neutrons added together. We're told that we have 36 electrons and 35 protons. We have 1 more electron than proton. That means that our element is going to have a single negative charge. So that is our symbol here. So pause the video now and see if you can work out these last two. So these are a little bit simpler because they go ahead and give you the name of the element. But go ahead and try and work those out on your own. Alright, so we already know that fluorine is the element here. So we can go ahead and put in the symbol for that. We're told that this is fluorine with 10 electrons. If we look at fluorine on the periodic table, what we will find is that it is element number 9. So if it has 10 electrons, that means it has 1 more electron than proton, and so it is going to be negatively charged. And since we're not given any information about the neutrons, we're just not even going to worry about the mass number. Most of the time the mass number is not needed. Beryllium, with 2 electrons. Beryllium is element number 4 on the periodic table. So if it has 2 electrons, it is going to be 2+ is its charge. And once again, because we're not given any information about the neutrons, we're just going to leave the mass number off. All right, we'll call it there for the day. In the next video here, we're going to talk about the periodic table and where it came from. So we'll see you in the next video.